Hi, this is Captain Steve Tarrant from Maine Maritime Academy, and in this video we'll be going through the solution to another trim problem. So this is problem 3 on the in-class worksheet if you're in NS 301. And this is a pretty simple trim problem as trim problems go. In this situation we have a vessel that has a forward draft of 1903 and an aft draft of 2103. That means we have a 2-foot drag where the stern is 2 feet deeper than the bow. And we're going to pump water into a spot that's 200 feet forward of, in this case, the longitudinal center of gravity of this forepeak here is 200 feet forward of amidships. A lot of times when we're thinking about this, we think about it in terms of the center of flotation, which is near amidships, but usually not exactly at it. We're not going to worry too much about that for this problem. So the question is, how many tons of ballast must be pumped into the forepeak to bring the bow down enough, here you see this, we're pumping in there, to bring the bow down enough to bring the stern up enough to give us a drag of from 24 to 12 inches. And we're going to have to use the stability data reference book for this. So there's sort of 3 steps to this problem. Okay, you can think about it like this. We have to figure out what the required change in trim is going to be. Okay, change in trim, or the trim change, that's going to be abbreviated here by T, C here. After we do that, we're going to calculate the mean draft and extract MTI from the deadweight scale. MTI, or moment to trim 1 inch. That is how we're going to figure out how what distance, okay, to place a weight. Okay. Well, actually, we know that distance is 200 feet, but we're going to figure out, since we know the distance, what the weight will be that we're going to have to load at that distance of 200 feet in order to have that trim change the way we want it to. And we'll solve for W using this formula here. Okay, since this formula depends upon moment to trim 1 inch, we're going to have to get that moment to trim 1 inch value from step 2. And then we will solve for W in this 3rd step using this formula, which we'll break down a little bit more in a minute. So, step 1, we're going to calculate the required change in trim. Well, we start off with a forward trim initial, that's an I there, of 1903. And the aft initial trim is 2103. So, what's our trim? Well, our trim is 24 feet by the stern, okay? Well, we want to have a final trim of 12 inches. So we're starting off with a trim of 24 inches, but at the end we're going to want a trim of 12 inches. So what we're going to have to do is we're going to have to subtract 12 from 24. And that's going to give us a 12-inch change in trim. We're starting at 24. We want to go to 12. We have to remove 12 inches of trim. And we're going to do that. We're going to have to change our trim towards the head. We'll still have trim to the stern, but we'll change it a little bit to the head by 12 inches. So step 2, now we got to get MTI. Okay, well, in order to get MTI, we need to enter the deadweight scale. All the values of the deadweight scale are dependent upon either the displacement of the vessel or the mean draft of the vessel. We don't have any information about displacement for this vessel, so we're going to have to go into it with mean draft. So what's the mean draft? Well, turns out that if we're at 1903 and 2103, our mean draft is 2003. So now we're going to go to the deadweight scale. And we're going to have to find 2003, and then we're going to slide over here until we get our moment to trim 1 inch. So we put that on there. And if you look at that, that's 1,000, that's 1,025. That looks like 3/5 of the way there, so that makes it 1015. MTI for a mean draft of 2003 is 1015. Okay, that's foot tons per inch. Okay, so step 3, solve for W. Well, it turns out that this formula here, trimming moment, I could abbreviate trim change equals trimming moment divided by MTI, but this trimming moment has 2 terms in it. Any kind of moment is a weight times a distance. Okay, so the moment to trim is going to be a weight times a distance. Well, we know the distance, it's 200 feet. It's the weight that we don't know. We know what the trim change is going to be. We got to change it by 12 inches. We know what MTI is. It's 1015. We have to solve this equation for W. Well, when we rearrange that, W is going to equal trim change times MTI divided by distance. So 12 times 1015 divided by 200, 60.9. And that is the distance that we will be putting we'll need to, excuse me, that's the weight, 60.9 tons. If we pump that 60.9 tons into this tank, we will decrease our trim from 24 to 12 inches. And that's how you do that problem. Thanks.